Okay, I'm George, and it seems that I make the S sound very distinctly, like a snake. Oh, wait, no, that one was on purpose, but, I don't know if it's my, computer's microphone or something, but, you'll be hearing a lot of S sounds. Uh, Not entirely my intention, but it happens. So what we have here today is, I'm making a program. It's actually one of my assignments that's due next Tuesday, but I thought it'd be cool if I, just went through this and recorded myself, and maybe it'll help others. That'd be great, actually, but mostly it's to help myself, and we'll see how this goes. So right now, on the left here, I have my node class. The thing we're doing over here, in case you don't know, it's like the singly linked list thing. I'm going to extend this one. I forgot to do that, actually. Node. So we have our very basic node class. I actually wrote it myself because I was a little unsure about how nodes worked, and I wanted to practice. So we have this. We have our basic things. You can tell that the object and the node they're private. So we have methods for accessors and mutators. I think that's what they're called. And these are public, so we'll be using these four. We've also got two constructors here. We've got the basic default constructor and sets stuff to null, and we have another constructor where if you want to be a little more detailed, you can do that. And that's all there is to see for this node class. Here's my actual assignment. So it's called set. I did not come up with this name. It's what it's called. And according to the project description that you guys can't really see right now, other than being due next Tuesday, it's a singly linked list with a dummy head. So instead of the head just pointing to the first element like it usually does, the head by itself is a node. It contains an object null, and it points to the first element if it exists. Otherwise, it points to nothing. So it looks like one of the specifications for this project is that it's a set, kind of like a number theory set, if you've taken stats or something. So you can't have doubles. So I actually did this a little earlier. Basically, whenever you add something, first you want to check by traversing through the list, and I can probably remove this. So basically you go through the list, and if that thing you're trying to add is already there, you just tell the user, okay, well, this thing's already here, don't need to do anything, got it covered, and just get the heck out of there, just real quick. And otherwise, just add it like where they specify. I have add last and add first because I was being fancy, but I don't think that's actually required. So yeah, other than that, I'm actually just beginning this project because I have to have like 10 other methods, and this is gonna be fun, I hope. Let's take a look at what I have so far first. So we have public class set. It extends node, so we can use these public methods to manage our individual nodes. And right off the bat, we can see we have our head and our tail and size. I don't think the tail was actually required, and same goes for the size, but they're nice to have, and you're not really losing much by including them there. So our constructors, we have two basic constructors. The first one's the default one, in which we aren't given anything, so we're not making anything. We just have head as its own node because we have a dummy head, and we set tail to head because really all we have is the head, so the tail is the head, and we have a size of 0. So our second one is public set, and we are given an object, and this object is going to be the data value that the first node is going to contain, not the head, the first node. So we're going to set head to a new node, and that new node, we're going to pass it the object null, so that head node is not going to contain anything, which is our intention, and that head node is going to be pointing to another new node, and that new node is going to have our object that we were just passed, and it's pointing to null. So basically what this does is it creates a two-node system. The first node is the head, and the second node has the elements that we were just given. And then we set tail to head.getNext, so the tail is where it should be, and because we only have one node that actually has meaningful data, we're just going to set the size to 1. And that'll be our constructors. I currently have 4 working methods. We have the very basic add first, add last, remove first, remove last. I have these if statements to check if what kind of list we have, because depending on whether you have 0 nodes, 1 node, or 2 nodes or more, you might have to do some different operations, account for the fact that you can't just set something to null, or you can't get next a null node. So that could cause some problems. Hopefully these if statements will kind of circumvent that. And so this is the method that I'm working on right now. It's public boolean contain. It takes an object and returns a boolean, and it looks like what this is supposed to do is, according to the project description, it says returns boolean value. Return true if the given object is contained in the set, and false otherwise. So what we're going to be doing is we have to search through the set to see if it contains object O. So we're going to have to traverse through the set because, even with an array, you're still looking at each one. But by traversing through the sets, we're going to check each one by itself. And if we find it, we're going to return true. And otherwise, if we're done traversing, we're going to return false. Okay, so how are we going to do this? We're going to make a new node called trav. It's going to be kind of like a pointer. We're going to set it to head first because we're starting at the beginning of our list, and we're going to go down. Okay. Alright, so first, we don't want to throw trav into the abyss, if you will. If there's nothing after trav, we don't want to try to force it to traverse to the next node because that'll give us an error. So what we're going to do is we're going to make an if statement. So if trav.get next, cannot type, but you will get used to that. If that's equal to null, then that means we're done with this. Okay, well, if the first thing we do is check if trav has something else and it does not, then that means head has nothing else. And that means this set is only head. So we're going to print out, because this is pretty rare. You don't search an empty list. Are you, maybe if you have, okay, people joke about Down syndrome. It's actually pretty serious, and you shouldn't joke about it. So if people are just dumb, they will probably search for an empty list for an element, or maybe maybe they don't know that it's empty. So we're just gonna go ahead and tell them system.out.println this list, or sorry, set is empty. Oh man, it's always awkward when I miss that. Okay, so we can tell them they're empty, and then it says return false if you can't find it. Well, of course we didn't find it, it was empty. So we're going to return false. You can tell I'm going to be an expert computer programmer because of my terrible typing skills. Okay, so that's the first scenario if the list is empty. Now, if the list only has 1, I don't think that's not going to be different from if it has more than 1, because we're only searching 1 individually, right? So we're going to have an else. Else if just else, because if it's not 0, then we're good. Trav dot get next. Wait, no, we don't need a condition for else. Come on. Okay, so now we're gonna can I just do this with one while loop? No, you want to tell them if the set is empty though. Okay, so that takes care of that. Okay, so while trav.get next is not equal to null. So we have something else we can go to. We're gonna do trav. Alright, so trav equals trav.get next. We're doing this first because right now trav, or the first time we do this, trav is going to be pointing to head. And obviously head's not going to have what we want. Head is an empty node. It points to the first node, but it doesn't hold anything. So we're going to do trav equals trav.getNext, and that'll give us the first node that probably has meaningful information. And now we're going to do a comparison. So I have this code from before, from when I was doing the add. So it looks like, what's this say? If trav.getElement equals 0, wait, no, that's O. Yeah, that's an O. So if it equals the object over pass, okay, yeah, we can use that. So we can copy that. Such plagiarism. I am bad at Linux or Unix, whatever it's called. Okay, so if it equals object O, we're just gonna return true, and that'll be easy peasy. Okay, so yeah, so if it equals that, then it'll return true, and otherwise we're gonna keep on going through a while loop until we're done doing a while loop. And if we go through our set and we can't find it, I guess we're just going to return false. Yeah, I think that covers all our bases. Alright. What's next? Public Boolean remove. Okay. And okay, it says returns Boolean value. Got that. Returns true if the node containing the object is removed from the set, and false otherwise. Wait, so does it take in an object? I guess it does. Yeah, okay, I'm gonna go ahead and assume it takes an object, because otherwise they'd be passing in a node. And I'm not an expert at computer programming, but I'm not exactly sure how one would go about doing that anyway. I mean, like, reasonably through a user input. Right, so basically it's gonna be a search and destroy mission instead of contain. Contain is similar to this, but we're just gonna say if it's there, we're gonna use it. So we're gonna copy most of it because code reusability is very nice. That's not it. There we go. Is it this one? Okay. But we're gonna change it because if we find it, then we have to remove it, which is we know how to do that. It's fine. So we have if trav.getNext is null, it's empty. Okay, yeah, whatever. No, it's fine. So here is where we actually find it. So trav.getElement. Okay, so right now here's the problem. Trav goes to the node and then checks the node for the elements, and it works well if we're just checking if it's there. But in order to delete a node in a singly linked list, it's usually a lot easier to delete the node after the node you're currently on. So in this case, we actually have to plan ahead, and instead of a .getElement, we're going to want to do a trav.getNext.getElement, so we can know that the thing contains what we want before we're actually there, and then remove it from the one that's before it. So unfortunately, this part of the code is going to be not very helpful to us at this point, but we're going to see what we can do with this. So okay, and we actually need an else if here, because since we're our range technically is going to be 3 nodes, so we're going to need 3 situations. So this situation is going to be when trav dot get next, dot get next is equal to null. Okay, so what this means is if we are on the head right now and we do trav.getNext, that gives us something that's not null because we already checked that. But then if we only have one meaningful element inside our set, then we can't do trav.getNext set or get element because you'd get a null. So basically we can just handle the situation right here. It means that we only have one element, so we're going to do trav equals, if trav.getNext dot get element dot equals O, is that right? And then we handle it. I'll get back to that in a sec. And then to return true, right? Alright. And then no, that's just the if statement, and then else. Okay, now let's do this. So basically this is for what if there's more than one node. So in order to plan ahead in this case, while trav.getNext is not null, trav equals trav.getNext, okay? And if trav.getNext.getElement equals O, return true. Oh, we have to deal with it though. Cannot deal with it. And once we're done tussling with that while statement, we'll just, or while loop. Yeah, we'll just do that. Okay, so how are we going to deal with this? If I was a white girl, I would... Come on, man, your parents are going to be watching this. Stop doing these cultural references that they'll never understand. Oh yeah, my voice is getting kind of hoarse, huh? Man, I actually like talking, but I'm not good at talking for a very long time. You know what, we'll see how this goes. So, right now, trav is pointing to the element before the element we want to the node we want to remove. It's pointing to the node that before the node that we want to remove. So what this means is, in this case, there's only one node. So we can just do trav.setNext to null. And basically by doing this, it'll cut off... Damn it. We have a tail to worry about. Okay, so we have a tail. Tail is going to be equal to head, because in this scenario we only have one meaningful data. So once we remove that, the head is going to be the only thing that's left, and tail will technically be the head. So we're going to make tail point to head, and then we're going to make trav.setNext into null. So that'll cut off the last one. And garbage collection is just going to clean that right up whenever it's not too busy with video games or something. Okay, so that's that. Now, this one might be a little more complicated because we actually have to join. There's two things we have to do here. We have to cut the connections that are holding the node that we want to delete, and we also have to rejoin the connections for the ones after that. So we have trav here, and trav is pointing to the node in front of the node we want to delete. So we don't want to delete that, sever that connection yet, because we still have to relink it again later. So we're going to make another temporary node. So, oh man, I am not good with Unix. Node. What is this? What do we want to call this? Temp? Do we already have a temp? Okay, let's call it temp. Temp and trav working together. I'm going to assign that to trav.getNext.getNext. So this will assign this. So now basically the node that we want to remove is surrounded. We have a pointer to the one in front of it, and we have the pointer to the one behind it. Okay, so we're going to start by severing the connections. Let's do temp.getNext, so that's the node we're deleting, .setNext, and I'm going to set that to null. So we've severed one of the connections, and now we're going to do temp.setNext to temp. I'm dumb. Hold on. You guys probably already caught this error if you're smart, but it's supposed to be trav. Trav is the one in front of it. Okay, so we're going to set trav.next to temp. And what this is going to do is it's no longer pointing to the node that we want to remove. Instead, it's pointing to the node after that. And that's basically a 2-in-1. It'll cut the last connection and it'll rejoin the links. So that should be it for this. Is it really that simple? Okay, so what if the node we want to remove is the very last node? So what happens then is if that's the very last node, trav.getNext.getNext is not equal to null, and okay, so node temp is equal to trav.getNext.getNext. But that's okay, so that's where things start to fall apart. So we have to check if trav. So we have to check if that's the tail. Okay, so if that's not too bad. Tail. We can check for equality between nodes by checking the objects they contain, because we're not going to have doubles. So if tail dot get element is dot equals, right? If tail dot get element dot equals trav dot, what's trav pointing to right now? Trav is pointing to the one before it. Trav dot get next dot get element. Yeah, these if statements are crazy. Okay, so if it's the last one, what do you have to do? We want to move tail first. Tail is now equal to the thing trav, right? Yeah. Now tail dot set next null, and oh, we have to decrement the size, don't we? Since I can't believe I actually forgot about that. You guys gotta tell me these things. Size minus every time we return true. Alright, where was I? Okay, so we've removed the node, and we're gonna return true now. I don't think that's right. Else. And just gonna indent this stuff. Okay, so now this should be more or less idiot proof, right? Get a drink. Okay. So this looks good. Wow, it's a lot of writing, but okay. What's our next method that we have to do? Add elements. Oh wait, so that's just Wow. Okay. You mean we didn't need all this stuff? I'm assuming they want an add last because it's a singly linked list. Actually, I don't know. I mean, I don't think order actually matters here, right? So, what is it called? Add elements? And it returns a Boolean value. Returns false if element is added because it's already in the set, and true if that element is added. Okay. Return true. And no, I guess we don't need that statement. We're just gonna do this. False. And that looks like everything we need to know. Okay. That was a really easy method. I mean, yeah, I already did most of it and then realized it was overkill, but okay. What else do we have? Size. Returns an integer equal to the number of distinct objects that are in this. Okay. Well, it's a good thing I was keeping track of the size earlier. Public int size. And it doesn't really take anything. Okay, I take back what I just said. That was the easiest method. Okay, subset of public Boolean Okay, this is, it's a static method, and it takes in two sets and compares them, and, you know, returns a Boolean value. This video is getting pretty long, and I think I'm just gonna cut it off here. I might just, you know, call it a night, but we'll see. I'm not actually good at making these videos, you guys probably already know that. So, yeah, good night if you don't see another video. Otherwise, I'll go take 5 or something, I don't know.